Hey everyone, welcome back to our channel. I am Ankit Malik. Today we are deep dive into a lower level API of Hugging Face Transformer. We will explore two crucial components that AI developers should understand: bits and byte config and model quantization, and auto model for casual LM for loading language models. By end of this video, you will know exactly how to run large language models efficiently on your hardware. Let's start. I will install necessary imports. The problem why quantizations matters. Let's start with the real problem. Modern AI models are huge. A model like Llama 3.18 billion parameter. If each parameter is stored a 32-bit float, there's roughly 32 gigabits of memory just to load the model. Most consumer GPU do not have that much memory. This is where quantizations come to the rescue. Think of quantization like compressing a high resolution image. You reduce the fill size with keep most of the quality. Instead of using 32-bit of each number, we can use 8-bit, 4 bits or even less. Here's the magic of model that would normally take 32 GB can be squeezed down to 4 to 6 GB with 4-bit quantizations. This means you can run powerful AI models on a regular gaming GPU. Okay, let's start with some coding from google.colab import user data from Hugging Face Hub import login from transformers. Run the cell. Now log in my Hugging Face. HF token is equals to user dot get HF token token add to credentials. रन करते हैं. Token has been set. Get token has been set. Credential Apple. Okay, no problem. Next cell. Here I will define my old models. Llama model llama slash 53 Microsoft slash 53 mini forecast instruct Gemma 2 Google slash Gemma 2. Here I define my old model's name. Okay, in Excel. Here I create a simple message array system content. You are a helpful assistant. Role user. Tell me a light-hearted joke for a room of data scientists. मैसेज डिफाइन कर लेते हैं हम अपना. Now define quantizations configurations. Config equals to bits and bytes config. Load in 4-bit row. Load in 4-bit towards control. Okay, let's run. Okay, now let's talk about bits and byte configuration. This is our control panel for quantization. Let me break down its settings. Load in 4-bit row. This is like saying compress everything to use 4-bit per number instead of 32 bits. It is a main switch that reduces memory about 75%. BNB 4-bit use dual quant row. It is a clever trick. It is like compressing the compression. It applies quantization twice even after better memory savings. BNB 4-bit compute type torch.b float 16. When the model does calculation, it temporarily converts to this format. B float 16 is a good balance between speed and accuracy. BNB forbid quant type NF4. This is a compression algorithm. NF4 stands for normalized float 4 bits. It is especially designed for neural networks and give better quality than regular 4-bit compressions. Okay, this is our old configuration, bits and byte config. Next shell. Here I define my model. Model is equals to auto model for casual LM dot from pre pre-trained auto model for casual LMs. I think why this is giving me error. Auto model for casual Llama device map auto and quantization is equals to quant config. इसे रन कर लेते हैं. Auto models is not defined. Auto model from casual LM. Yeah. Now let's understand auto model for casual LM. The name sounds complicated, but it actually quite simple. Auto means it automatically figure out what type of model you are loading. Models means the actual AI model. For casual LM means casual language model. It means it predict the next word in sequence. Here is the each parameter does from pre-trained download, load, and pre-trained model from Hugging Face. It's like downloading the trained AI brain. Device map equals to auto. This automatically decide which part of model go on GPU versus CPU. It is having like smart assistant that organize your workspace. Quantization config. This apply our compression setting we defined earlier. The beauty of auto is whether you load Llama, GPT, or any other model, the same code works. Wait for complete execution of this code. Till then our model is downloaded. We can write future code. Model, and here we define our tokenizers. Tokenizer, tokenizer equals to auto tokenizer from pretrained Llama tokenizer dot add token is equals to each token input is equals to tokenizer dot apply chat template message add return equals to p2 dot kuda dot to kuda. Wait for execution this cell. Okay. Wait. Okay, now my cell execution is complete. Print model. Okay, let's peek inside a transformer model to understand what we are actually loading. We print our model. We see several key components. Embedding layer. This layer converts word into a number. Think of it as a translator that turns human language into mathematical language that AI can understand. 32 decoder layer. This is our thinking layer. Each layer refine the understanding step by step. It's like having 32 editors review and improving a text. Inside each decoder layer, you will find self attention. This helps the model understand how words relate to each other in sentence. MLP, multi-layer perceptron, this does the actual thinking and transformations. And layer normalization, this keep the number stable during process. And LM head, this is a final layer that convert AI internal understanding back into probability score for each possible next word. Notice how the quantization model show linear 4 bit instead of regular linear layers. This is compression in action. Okay, let me explain this line. Tokenizer is equals to auto tokenizer dot pretrain. This loader tokenizer, think of it as a translator that convert human text into numbers that AI can understand. Each model has its own language of tokens. Tokenizer dot pad token is equals to tokenizer dot EOS token. This is crucial where when processing multiple text together, they need to be a same length. Shorter text get padding and is with the special token. We are telling the tokenizer to use end of sequence token for padding. This is like a periods to fill each empty space in sentence. The model knows to ignore these padding tokens. And fourth, input is equals to tokenizer dot apply chat template. Message is equals to return tensor pt dot CUDA. This is a fascinating different model expect different conversation format. Llama wants to use our hello assistant while other use different style. The chat template automatically format our conversion correctly for each model. Let's run this code. List object has no attribute to to. Okay, check करते हैं इसे. Okay, return tensors इसको print कर लेते हैं. Okay. Okay, now I use my model with quantization configuration that I said here. Output is goes to model, yes, model dot generate maximum tokens is 30. Print tokenizer dot decode output 0. Let's print action. You this attention. Yes, now my model generate response like you are a helpful assistant that my input EOTID start header and the response. Why did the logistic regression model go to therapy? Because it is truly struggle to classify the emotion. Yes, is here my model generate response with these configurations, quantization configurations. Okay, the code. Let's define a function generate. Here I will pass model comma messages message tokenizer auto tokenizer dot from pre-train model tokenizer dot back token is equals to tokenizer dot es token input apply chat template kuda streamer text streamer tokenizer model is equals to auto model for casual LM quiet configuration streamer. Okay, let's define here as well comma add generation prompt is also false true. Okay, run this function. Okay, now experiment with different models. First, now experiment with phi 3 generate phi 3 comma messages. Here I will define phi 3 and a message. Run this model. Okay, 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 okay. Executing cell. The amazing thing is that same code work for all them. Our generate function handle tokenization, model loading, text streaming automatically. Look at the memory usage with quantizations and 5.8 GB disk and system RAM. With quantization, our 8 billion parameter model use only 5.6 GB instead of 32 GB. That's the power of bits and byte configurations. Here the GPU usage is 5.8 GB. This is due to quantizations. Let's see the response. Till then I can listen, continue my song.
Code infinity, let your mind ignite. With LLM soaring, reaching new heights. Join the journey, let's explore the sea. In a universe where knowledge is key. From algorithms to neural.
Okay, my response generated. Like my messages, you are a helpful assistant, system and user. Tell me a light-hearted joke for data scientist. Here the response. Why did the data scientist break up with the algorithms? Because it always calculating the wrong variables in relationship. Okay, this is response from 5 model, and you can experiment with different model as well, like Gemma. Okay, let's wrap up this video. Have it now you understand bits and bytes config and auto model for casual LM work together to make large language models accessible to everyone. The key takeaways are quantization dramatically reduce memory usage, bits and bytes config give you precise control over compression, auto model for casual LM makes loading any model simple, tokenization and chat template handle text formatting. The same code works for different models families. If this video helped you understand Transformer internals better, please give it thumbs up and subscribe for more AI development tutorials. Now I'll finish with Code Infinity outro song.
Reaching new heights, join the journey, let's explore the sea. In a universe where knowledge is key. Unfitting.
Bye bye. Thanks for watching, and I will see you in the next video. Bye bye.